Hello, party people. I would like to invite you to this little talk, Snapcrafting on a tablet, a little adventure. As a little disclaimer, this turned out to become a completely different topic than I actually wanted to provide and talk about, because iPads and tablets in general, they don't necessarily follow what you expect. I will show you later what I mean by that. But the agenda here is, first of all, the attempts of using Snapcrafting abilities on an iPad using various techniques, which failed horribly. The second one is attempts on Ubuntu Touch. And since that one takes most of the talk, I will also sneak in some device integration for Ubuntu Touch, how to get Ubuntu Touch onto your tablets, and how to improve Snap integration in the long run. What are the missing pieces at the moment, and where it can go. And what to expect is a little bit of C++ tooling, Snapcrafting, WebAssembly, if you have heard of that or not, tablets, because they're cool, iPadOS, Ubuntu Touch as a comparison to that, and multi-platform app development, and how to do system integration on a level below an application. So, and what I want to talk about specifically, also what to gain from this talk, is a comparison between two different beasts. It is apples and peaches to a certain degree, but what can we learn from other platforms? What can we apply on our platforms? And how can we interchangeably make those things work properly? Building apps for an ecosystem. How can you work inside of an Apple ecosystem versus how can you use Ubuntu Touch to work for and with the broader free and open source communities? And learning from my failures. Please don't attempt this at home. So, why a tablet? There are so many arguments against the tablet that I've read on the internet. I have my beef machine at home. They're so clunky to use. Software is limited and intentionally held back. But when I take the iPad, for example, whenever I hold an iPad, I wonder how to develop with it, not for it. So I'm always taking this thing in my hand and wondering, hey, this actually feels nice. This actually works. This actually provides a good, fluid experience. How can I make use of that in a development scenario? And then later on this year, actually, Apple released two professional tools for their platform. First of all, Final Cut Pro. And second of all, what's it called again? Someone with Apple knowledge knows what the... Logic Pro, exactly, yes, thanks a lot. Logic Pro, which is basically their professional tooling for video cutting and audio production. And I was sitting there and wondering, can we have professional development tooling on a tablet as well? And for that, we should just check out what the iPad has to offer. Raw horsepower is insane. So the M2 chips, and this is not an advertisement for it. You will see later why this is not an advertisement. But the same M2 chip in both the iPad Pro and the MacBooks, and the MacBook Air specifically, this one running this presentation at the moment, is insane. So the raw horsepower with an ARM 64-based machine that you can get nowadays is phenomenal. You can put virtual machines to a whole nother level with this in case you need to use a virtual machine on a Mac environment and run Ubuntu in that, or run it natively also. That also works. In my opinion, the user experience is very good on the Apple platforms. They provide very good user-first experience for ordinary users, which is also very important for their success, to be honest. Accessories, making it work for work. Another argument for a tablet. There are a lot of tablets with accessories, but not so many with the level of abilities like the iPad has. And developer tools are actually in the App Store. So there is a Git app called Working Copy, which you can use to pull and clone and push changes to various repositories. There's a documentation bureau, and there are mostly online IDEs as well, so you can do some limited development on an iPad as well. But how do we compare with that? Why Ubuntu Touch, for example? And the goals are similar to the iPad. We want to cover average consumer-grade needs first and foremost, using similar things that happen to be similar between an iPad and an Ubuntu Touch device, read-only file system, confinement rules that don't allow an application to break out of the system's environment that the system has set up for it. But we do have a low to mid-tier selection of hardware at the moment, so we don't have a lot of it. Actually, I should have worn this jacket because this thing has enough space for me to carry an 11-inch tablet. And this is a tablet by a now defunct company called Jingling. This is the JingPad. This is one of the rare devices that actually can be used with Ubuntu Touch as a tablet, but it also has this clamshell keyboard accessory. So you can use it as a desktop, or a laptop rather, but also as a tablet if you choose to do so. And we can have a desktop mode that matches nothing else. Nothing else comes even close to that, because we have a terminal, we have desktop mode, and the tablet turns into something that you can actually do work with, serious work with, potentially with the right tooling. And so we can have regular Git. We can have all the development tools that you're regularly used to. Even VS Codium, we have that in the store, and we have that in Snap Store. So I was thinking maybe my own little tiny IDE that I will cover later on would also fit in there to package it all up. So as a little resume here, why a tablet? They arguably look cool, right? And different way of thinking, Galaxy brain powers. They are very easy to carry around with. I mean, I was able to pull it out of my jacket right now, out of the pocket of my jacket. So that speaks for portability of the device. And some claim in the Apple sphere and the YouTube sphere that this is a fresh start for computing devices, for personal computers. And I can see some of those arguments, because you have to rethink a little bit of how to use a device compared to the regular desktop or laptop clamshell device that you're used to. And also, there are new ways of chaining apps together to complete a task. So you do have the ability to take input from another application, process it in yours, pass that data on to something else. Very much like piping together CLI commands, just in a graphical user interface way. So for me personally, to achieve the Snapcrafting goal on a tablet, I figured I want to put those two beasts next to each other and compare them. What can you do with it? So here are the rules. It needs to be an ARM64 tablet, because iPads are only ARM64 available. So the JingPad counts in that group. Totally works here. It needs to do everything offline, so no cheating, no shelling out to a different server and running shell commands there, no Snapcraft on a server on the remote. And debugging also, possibly, potentially. And the focus is on creating CLI applications first, because graphical applications on an iPad would be a little hard to pull off. So let's allow the iPad to at least shine a little bit. And the way that I wanted to achieve this is with my little shameless self-plug here, Tide IDE, which is a multi-platform development environment, which currently allows to run WebAssembly on the iPad, on macOS, and on Linux. And in the future, or at least that's the goal right now for me to pull in is Snapcrafting abilities and click packaging for Ubuntu Touch devices, so that you can write an application and build it on the device for the device, and potentially for other devices as well. And with that out of the way, the snaps to craft. Which snaps do we take as an example on proving that Snapcrafting on a tablet is actually possible, feasible? Git confined is one of them. So Git confined is my little all-in-one Git flavor for confined environments. So Ubuntu Touch, tested on Ubuntu Touch, developed on Ubuntu Touch, actually, first and foremost. Not to jump ahead of myself right now. But it's got the regular Git feature set, so HTTPS clones and pushes, SSH, man, whatever is inside or used inside of Git repository that is built as part of Git is inside of Git confined. It just follows the rules of the respective packaging format, in this case, Snap. So you install it as a confined Snap. It only does have the permission to work in home and on remote, removable media and networking. That's it. More than that is not really needed. So this is a self-contained, self-hosted Git chunk of Git that you can actually use, put to use. And the second one is Clickable. Clickable is our Ubuntu Touch packaging tool for developing apps on an Ubuntu or other Linux-flavored desktop. So the idea would be to pull Clickable into a Snap package, install that, and then have it build a regular Ubuntu Touch application for you. It requires Docker, so there are going to be some issues, or there is some issue at the moment, which makes it hard to pull off on a tablet, but with a little bit of tricking, it works, and I will show you later on how that is possible. Those are the snaps that we want to craft now. How about the boundaries that we are working within? Because this is two different beasts. What are the boundaries of the Apple ecosystem, and what are the boundaries that we have set up? So iPadOS has serious limits, and those are making it hard to pull off the... This is basically the reason why my experiment failed on the iPad. You don't have the ability to allocate memory and call it executable, because Apple, in their infinite wisdom, claimed that this might be, and it might be a valid reason to not be allowed to execute randomly allocated memory, but it disallows just-in-time compilation. It disallows ahead-of-time compilation in some cases, or in the same case. There's no way to spawn other processes, but other than that, it's got mostly legitimate sandboxing techniques. And the reason for the executable memory not working out is because every allocated memory chunk that is executable needs to be code signed by Apple. You need a signature from Apple that this application is allowed to execute randomly allocated memory, which means no just-in-time compilation for any application in the App Store. And manual reviews by Apple employees are also important. You can't just fire and forget a release of an application. Even though they run inside of a sandbox, the Apple employees working at the review team, they still need to take a look at it and either give it a thumbs up or a thumbs down and just release it after a little period of verification, so to say. What boundaries do we have in Ubuntu Touch land, though? So we do have two models of supplying applications. First of all, there's the confined ones, the regular click packages that we currently ship, that we currently have, that we're happy with, in a confined environment, but also in an unconfined way, where the application is allowed to do pretty much anything that it wants to do. For confined applications, they can be released immediately. They can be put in the store right off the bat, right as soon as you want, and at your own cadence. But unconfined apps, they need to be, first of all, free and open source software so that they can be reviewed, and they will be reviewed. So you can't just put an unconfined click package into the open store and infect some random user's device like that. Well, I won't challenge it. I will not challenge it. Let's just put it that way. The boundaries that we also have with the iPadOS, coming back to this, performance matters. So no executable memory means no on-device just-in-time compilation and no on-device ahead-of-time compilation, which is something that my IDE would like to provide. Ahead-of-time compilation of WebAssembly would solve a lot of the performance problems, and why WebAssembly I will show you in a minute. But also licenses matter. for example, you can't just put a GPL piece of software into the App Store of Apple because of restrictions that are put on top of the GPL, which the GPL explicitly prevents people from doing. So it's completely incompatible with, so GPL v2 and v3 is incompatible with the way that the App Store at Apple Land does it, at least for the iPad, because of various reasons. The exceptions are those with linking exceptions, which separate the library from the actual application, so that the linking rules, so that the GPL rules only apply to the library, but not to the whole result of the program. This is disputable. Good luck with that. So I figured, if this is so hard to pull off, how about we just let virtualization technologies handle that? I mean, that's pretty much the first thought that comes up for anybody who wants to try this. Why not just run a VM and have everything inside of that? And we actually have two solutions here. UTM, which is a virtual machine manager based on QEMU for macOS and iPadOS. And we also have Pocket VMs. Shameless self-plug again. It's an application for Ubuntu Touch, also based on QEMU. And it even supports hardware-accelerated 3D using virtual renderer. And it would have been nice to put those two side by side, comparing those two, having the horse race do its thing. And then all of a sudden at my birthday, bad news. So Apple removed the hypervisor support from the kernel in iOS. And that means in this screenshot, you can just see the hypervisor trap function being not called anymore, and instead just returning an error code. Which means that you cannot, whenever you try to do virtualization on an iPad, it will refuse the job. You cannot do it anymore. Unless you stay on an older iPadOS version, in which case you don't gain any features whatsoever. And I really hope that this is, I hope you understand where this is going. This is like working with Apple.
The scream of fear, the ribs have gone there.
This is pretty much what happened to me.
This guy obviously wasn't watching, because he's out.
Okay, so that's my experience visualized in a little video. And so WebAssembly was the second idea that I came up with. And for that, because the IDE basically allows WebAssembly to run. And so the question rises, what is WebAssembly really? So WebAssembly is a target that a compiler can generate code against. That's pretty much the definition of WebAssembly. In this case, WASM32 is supported. Clang supports that, which I pulled into the iPad app to make it work as if you just compiled a little tiny emulator inside your tablet and run a Linux environment using that. Problem is, no just-in-time compilation, no ahead-of-time compilation. But in general, the idea is to put Linux, some version of Linux with Snapcraft into that and run it in the iPad's very confined environment that doesn't allow you to do much anyhow. So there is a very interesting little experiment here called, if my buttons work, there's a very interesting application called Container to WASM. So how would I achieve the goal of running a Linux environment for Snapcrafting on an iPad? Container to WASM would solve this, does actually allow running Snapcraft in this environment. So what is Container to WASM? It is Docker prepackaged into a little virtual file system that gets loaded into RAM along with the application. And it's got a pre-configured tiny emulator, which allows RISC-V or x86 64 emulation. Remember, no virtualization possibilities whatsoever. And Snapcraft inside of that. So it does allow for the theoretical functionality with lowest performance you could ever imagine. And it takes around 14 minutes for Snapcraft version to return. I was able to crush it down to 1.5 minutes by pre-creating the Pi cache and remove some unnecessary files. But in the end, you can imagine this was not a path worth pursuing. So this is where the quick end comes for the iPad. The iPad cannot do it yet. There are so many limitations that don't do the hardware justice. It just doesn't justify the capabilities, the potential that the hardware actually provides. And so I figured, if this is going to end like that, how can I make the presentation at this moment in time actually work out? So I figured, how about we take this route? You can take an iPad and write an application for the iPad or the iPhone using Swift Playgrounds. Ubuntu Desktop can build for itself and Ubuntu Touch. So itself and trickle down to the smaller device form factors. How about we flip the game and take the tablet and create a desktop application or a server application, CLI application for it, using the tablet. For that, we need a few changes in the base operating system at the moment in Ubuntu Touch. And that is improving the layers underneath the app. So forget it on Apple platforms. It's as closed down as you can imagine, and you can't change much of it. So that leaves us with Ubuntu Touch as the only contender, so automatically wins. But it still needs some changes, and that is Snapd integration is close, but not quite there. It still needs some changes on the Ubuntu Touch port side, or the system integration, as I like to call it nowadays, not a port. What is a porter? What is a port? But the system integration, right? So integrating the operating system into something that the device executes for and that a regular user can enjoy. This is where UbiPort's porting comes in. Responsible individuals get to shape the platform, because you can take the generic Ubuntu Touch rootfs. You can do your own adaptation of that generic Ubuntu Touch rootfs and make it pop on your hardware. Make it work seamlessly, make it work the way that you want as a system integrator, so that users can enjoy it, right? How can we further expand the capabilities? Because we have had some Ubuntu Touch changes with bin format mishandler, for example, which means that, for those who don't know, that a random, let's call it, let's say a wine interpreter gets registered in the kernel, and it gets used to execute an exe file automatically, without the user having to do anything other than setting the executable bit. We have that now. It's called Winebox. Wine plus box64 on a phone allows you to run Notepad++ on a tablet. So, cursed. But it works, right? But it still needs some changes in the kernel, especially with AppArmor and other little problems that arise whenever Android vendor kernels do something different from a regular mainline kernel. And I have to admit, we are stuck with old kernel versions. That's just the truth. That's just the reality that we're having to live with. So the Pixel 3a, for example, this device right here, which I would have liked to do the presentation with in the first place, but adapters, this one runs a 4.9 kernel, old, right? The Jingpad runs a 4.14 kernel, and so on and so forth. There are many, many other different devices which run older versions of the Linux kernel, and we need to adapt to those situations. And I would like to say this up front. If anything in Snapd land tries to, or Snapcrafting land tries to push further newer technologies, please consider keeping a little bridge between old and new, so that we as Ubuntu Touch can also continue benefiting off of Snap and making sure that snaps work on Ubuntu Touch as well. for example, I've noticed that the Docker snap, and this is something that will come up later, the Docker snap has issues generating an AppArmor profile with the Docker support interface that is parsable by the Snapd vendored AppArmor at the moment. So it fails using with an exit one about something about the regex being invalid. And this might have to do with those new expressions that are inside of the interface of Snapd that generates the profile. That's just the status quo. I would like to improve the situation together with you if you invite me to do so. And we can make sure that this works. The next slide I called a dance of apps. A little dance. And both contenders here, just bringing the iPadOS in again, just as a comparison to what we do have and what we can provide. iPadOS has the share sheet for passing single files or abstract content around to other devices, to other applications. And it also allows to share whole application folders, document directories over a kernel interface to another application, much like Fuse does, pretty much similar to what Fuse can do. Or basically bind mounting it into the runtime on the fly as soon as the user presses a button. Ubuntu Touch, on the other hand, we have something similar for the first task, Content Hub. This is for passing files or abstract content as well. But we don't have a sandboxed way of allowing Fuse in our open store. This is where the Snap Store might come in, because as far as I'm aware, there is a Fuse interface in Snapd. Am I correct here? Something that allows using Fuse inside of a confined application? Is that the thing? Okay. I would have to look it up as well, yeah. And this is what it looks like. So you have, here is again the screenshot of Tide, my little IDE that I'm working on. This is what happens when you release a WebAssembly application to someone. You can airdrop it, you can send it via various applications. You can actually pass it on to other applications using whatever predefined input method they want to consume it with. Like, for example, if this was a Python script, which also is supported by Tide, you can just pass it on to another Python IDE and execute it inside of that instead of the WebAssembly-ified Python runtime that I have. On the right side, we have the Content Hub for running on Ubuntu Touch. So you can take the file manager, tap an icon, and it will automatically ask you, well, what do you want to open this file with? This is more than just an open file dialog. This is passing not only files or directories, but the abstract idea of content. What is content? That all depends on what people figure out on themselves, the app developers want to provide. And this is something that works on Ubuntu Touch already. So we have the abilities. For example, it doesn't need to be a file. It could also be a QR code that is parsed by our QR code reader, and the contents of the QR code are just passed on to whoever wants to consume that QR code. So it's not file-based per se. It's just an abstract idea of how to pass on content. So quick result for now. iPad, incredible hardware performance, held back by its own software capabilities. Ubuntu Touch, on the other hand, because it's a little bit of an unfair game, if you want to say so, but if there were virtualization techniques, then it would look different. Ubuntu Touch could do it, can do it, but it needs the proper hardware to showcase that. And with that out of the way, I think we're half an hour into the talk. Now we get to how to Snapcraft. So right now, what we need to do if we want to take an Ubuntu Touch tablet and install Snapcraft onto it, it needs, first of all, Snapd installed in Ubuntu Touch, which we don't have shipped by default yet. This might come in the future. However we're going to solve this is still out in the air, still a dream, but we are working towards that. It's not finished. And as soon as it is finished, it will probably land in Ubuntu Touch by default. With LXD and privileged containers, everything works pretty smoothly. But LXD and the non-privileged, unprivileged containers currently expose an issue on Ubuntu Touch where they cannot spawn the container easily for various reasons, depending on which kernel capabilities are there. Remember the old kernel versions? That's something that we need to toy around with. Sometimes you need to disable a seccomp filter. Sometimes you need to do other things to enable the way of making sure that this is possible. With LXD privileged containers, everything works. Partially writable file system that we provide with Ubuntu Touch. So most of it is read-only. Some parts of it are read-writable. Those types of things are very similar to what Ubuntu Core does, but not quite the same. We need to figure out a way on how to keep in mind that even though Ubuntu Core works, the way that Ubuntu Core does it works, that we don't have to play catch up with Ubuntu Core, so to say. So whenever a new writable path gets added to Ubuntu Core, that we also figure that out very easily or get it very quickly, the information that, hey, there's a new writable path that you need to add. For example, something dbus related, a writable path for dbus service policies or something, which already is there, just as an example. And you need to run Snapcraft in destructive mode inside of that LXD container, which is a bummer, but it works to the degree that you can pull Snapcraft from the Snap Store. You can run it in destructive mode, and then you can throw away the LXD container later on in case you don't need it anymore. And it allows Snapcrafting with native performance, because this is pulling ARM64 Snapcraft into the tablet, executes it, and it's not held back by any virtualization technologies. It's not held back by any WebAssembly. It just does its thing. So now we have a situation where we can put Snapcraft on a tablet and develop with it. But how do you get to the tablet in the first place? This is where my quick end with the iPad experiment ended. And I want to provide a little overview of how to get an Ubuntu Touch tablet for yourself so that you can enjoy this as well, in case we don't support it already as UbiPorts. And for that, we have the system and device integration. So there are two approaches on how to do this. First of all, you can take something like the Pine devices, the Pine Tab, for example, or the Pine Phone, and take an as mainline as possible device that most people are familiar with, that provides a graphics stack, a driver stack that is familiar to most people in the Linux space. And there are sadly very few off-the-shelf options here. So Pine devices are some. There are others. I'm not going to name more than them because I forgot them. But there are certainly not as many choices that you can take a pick from. So the second approach would be Halium-based. So what is Halium in this case? It's just an abstraction layer for hardware access on a typical GNU/Linux environment using Android drivers. And we use the Android vendor kernels. We also run the mini Android services inside of LXC container so that calling works, so that sensor services that are in the user space actually are started, which is identical to the way that Ubuntu Touch did it in the past. It's just now under an umbrella term, which is shared by many other projects as well. And yeah, so Android libraries in a GNU userland, typically. And how do we manage to push those out to users? How do we get those out to a device system integrator? Or how does a system integrator push this to his users or their users? And that is a little complicated. Here are two examples of other distributions like Droidian or LunaOS, which each have their own ways of packaging Halium up for others to install it onto their device. For Ubuntu Touch, though, we have the generic Halium system image built on UbiPort CI, where the port maintainer, the system integrator, adapts the kernel to the level that it needs to be integrated in order to run Ubuntu Touch. So pull in AppArmor, for example, newer version of AppArmor, or patch it up to the way that to the point where it's actually feasible to execute a proper snap package with. On UbiPort's GitLab, we have Halium generic adaptation build tools, which is one of the repositories that you need to take a look at in case you want to port over a Halium device yourself. So off-the-shelf Android device, stuff the Halium bits in there, and making sure that it works on the tablet and you can use it then. This is separate from the also generic Ubuntu Touch rootfs. So there's one rootfs executing on all the Android variations and versions. They're just abstracted or separated by the Halium layer in difference. So that's pretty much it. And we then ship the whole package or the separate bits and pieces through system image, which some people in here might know or might remember. And AppArmor on Ubuntu Touch is a little bit hard as well. Again, old kernel versions. So what can you do? Either you remove and replace the security AppArmor directory, painful, but it works surprisingly well, especially on the Xperia X, where I did this in the past with kernel 4.4, and I just took the Xenial implementation of AppArmor, stuffed it in there, and it worked surprisingly well, to the point where you can run snaps on that one as well. And second approach, though, is taking the patches from AppArmor's GitLab and applying them to newer kernel versions in case they provide patch files for that kernel version. I would welcome some coordination on that front, at least some friendly talks about how can we improve the AppArmor integration, because we as device integrators need to ensure that the AppArmor implementation actually works well enough for snaps, right? So there's a little bit of burden on our side, and we would like to ease that burden by having a little conversation on what to do and how to do it, what would be a preferable way forward. And in this case, I could also see Binder IPC working with AppArmor in the future, because Binder is the IPC mechanism on Android. It's the thing that allows to draw things on the screen, actually, because there's one process handling the display, there's one process handling the surfaces, and they actually don't use sockets, they use Binder instead, and that one is not properly mediated yet. So we need to mediate those things too, or I would like to mediate those as well, but it's not there yet, and I would welcome a little bit of a talk about how to manage those things in the long run as well. And the last bit here is how to improve the Snap integration in Ubuntu Touch itself. So Snapd integration planning and shaping is currently happening. I'm very open to input on the Snapcraft forums. I'm regularly pushing updates there on what is possible at the moment and what is not. Whenever I encounter an issue, I would really like to get some eyeballs on this, on those topics. The Jingpad users specifically, they got this device, many of them got it specifically for developing on it with Docker. And that always raises the question, when can we have Docker on Ubuntu Touch? And that's because of the earlier issue with AppArmor profile generation not working properly for our environment, where I would like to just get the ball rolling so that we can fix this issue. But CLI tools of other kinds, they work pretty well. And they so the Git confined works seamlessly, and the clickable thing also works, considering that you can, in fact, spawn a LXD container unprivileged, with privileges, excuse me, privileged LXD container, apt install Docker into that, and then pass the socket on to whatever environment is running the clickable snap. So this way, it's hacky as hell, but it works. And this proves it again. We can do it. And the additional permissions for GNU and Android hybrid userland, those are very important parts for us to integrate it well into our system as well, to be honest. I have pushed some preliminary, completely dirty patches. Of course, they are copy-pasted. They even have the NVIDIA references in there where I copy-pasted the original file from. But I would welcome to have some little coordination on how do you, as Snap developers, Snapd and Snapcraft people, how do you see this work out? How would you like to see this work out? Is there something that I'm missing so that I can implement it in a way that allows libhybris drivers to work? So the OpenGL drivers on Android, from Android, to work with a Snapped application together. So in practice, it already works. So OpenGL ES2, as tested with QML Creator, does work. And it allows to draw the shader and the shader example inside of that, just putting a shader on top of this texture and call it a day. It proves that it's possible, but there are some issues with, for example, Flutter applications not working properly at the moment. And also something that I would like to coordinate with you people with. So Content Hub and other Ubuntu Touch frameworks and services that we rely on are also not properly integrated at the moment. I remember that Snapd has interfaces for the Content Hub and Unity 8 and other things in there still. The problem is we renamed everything. It's not Unity 8 anymore. It's called Lemire now. And we had to do it sadly because of the fact that many people want it in their distributions, and we had to separate the naming from basically we had to import it into our group and call it something different in order for other people to consume it in Debian, in Fedora, in whatever distribution you want to run it with. So there is something that we need to do still to make sure that snaps work properly on the tablet and on the phone. And with that out of the way, if you have any questions, please go ahead. Thanks for listening to me rambling and failing hard in providing Snapcrafting environments on iPads. But if you're interested, we do have a few links and resources here. So ubports.com. Most of our source code and device integration port things are located in GitLab. There's also the halium.org site, which you can check out to figure out what this thing is actually looking like. Lemire.com for the desktop. And in case you're interested in a tiny little IDE, you can take a look at my IDE on GitHub as well. Thank you. So if there are any questions, I would just like to hear them. Yes, please.
So at the start, you talked about creating snaps and
Yes.
would you be interested in like developing craft so as an interior request to be easily transported as snaps?
Possibly, potentially, yeah. That sounds like an idea. Yeah. That sounds like an interesting approach. Yes, definitely, definitely. I mean, it depends on what it entails and what it contains as the whole workload. But sounds like an interesting thing for sure.
These have this need to settle on what we want to call the things like how it's called, like not the interface, there's
The permissions, yeah, right. So sort, yeah. Sure, yeah. Yeah. This sounds like an interesting thing, especially, I mean, sort of sounds like transpiling a click package into something that can run in a Snap environment or vice versa. I don't know.
Parts really neatly defined. I say very vaguely because the problems kind of you have.
Mm, yeah.
Once you have your part neatly defined on your click prop, that would basically just transport.
Yeah. This could be a path worth pursuing. Yeah, definitely. We can talk about this later on if you want.
And also, sorry, just one more question. You said you had to run Snapcraft in destructive mode inside the LXD environment. Was that because LXD
Yes. Yes, pretty much. So right now the issue is that user namespaces, although implemented on the Ubuntu Touch kernels, on the Android vendor kernels, they still provide some differences from the regular Ubuntu kernel, and those differences are hard to pinpoint. We need to figure out how to mimic whatever the Ubuntu desktop is doing or the Ubuntu kernel is doing. We need to mimic that as closely as possible in order to provide a similar feature set. So right now, the user namespaces are not there. And I also tried to, for example, with clickable, one way that I tried to put clickable into use is by pushing Podman into the snap itself, and have that one execute the compilation with the Docker images that we usually provide. Problem is that, again, user namespaces don't work on the Android vendor kernels as closely as they do on Ubuntu kernel. So we need to figure out something to fix that, but we're not there yet. But it's certainly something to take a look at and improve here. I noticed there's a new user NS. Yeah. I actually tried to play with that. The problem is whenever it's trying to spawn, and that might be a seccomp problem. I think it's because of the clone syscall getting completely ignored and refused with an eperm. So operation not permitted. It doesn't allow cloning the process into a new namespace, and that causes it to fail. If that is fixed, then we can have Podman inside of the snap and build Ubuntu Touch packages with that, right? That would solve it. And how to do that, or how to figure out what is actually causing the problem, I didn't have the time to figure that one out, but I would like to fix that. Mhm. Right. Yeah. Right. Oh, cool. Right. Yeah. I understand. Yeah. Mm. Right. Mm. Mm-hmm. Mm-hmm. Right. Right. Mm-hmm. Right. 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 I am able to take my Ubuntu Touch tablet and provide a piece of software, a snap, for an Ubuntu desktop user, which is unheard of, right? This is not something that you regularly hear people or developers do in their environment. Like create something that works on a desktop, but it's been developed on this low profile type of device, right? Mhm. Yeah. Yeah. Right. Oh, yes, exactly. Yes. Mhm. Yeah. And this Pocket VMs on Ubuntu Touch actually also takes care of making use of KVM. So it's regular QEMU using KVM. And I just had to tweak a few things for 3D acceleration to work, but now it works.